Okay, so we're going to look at the basic shapes of the three primary trig graphs. So when you're doing the three primary trig graphs, we just look at our unit circle. Okay? And we're going to look at the unit circle as it pertains to be in degrees. Okay? So we're going to look at the values in degrees. And we're going to come up using the unit circle with a basic sine graph and a basic cosine graph, and then tangent's not on there, but we'll figure out a tangent graph as well using our available unit circle. Okay, so first thing we're going to do is we're going to draw an axis for 360 degrees. Now, as you know, in the unit circle, the largest number you can get on here is 1 because of the radius. So our graph is only going to be able to go up to 1 for sine and cosine. Sine and cosine, x and y, can never be longer than r, because x squared plus y squared equals 1 in the unit circle. So if x is 1, then y is 0. If y is 1, then x is 0. So they'll never be greater than 1. So that's why we start with the sine and cosine graph. So we're going to do the basic sine graph first. Okay, so let's just do sine y equals sine x. It's kind of how we're going to do it. I'll do it in reasonably. So we're going to do a y equals sine x. Okay, so we're going to draw an axis. I'm going to use a t-graph like this. Okay, we're going to come up and we'll put a 1 here. Okay, and I'll draw this graph. We'll put our 1 and our negative 1 on it. Okay, and then 0. Okay, and then we'll do our degrees in the middle. So this is y, and this is x, and this is in degrees. Okay, we're going to do it in degrees, not radians. We can do it in radians later. Okay, so if we start at 0 degrees, and then we could slice it into. Okay, if you look at the unit circle, and we go 90. 180, 270, and come back to 360. That's where we get our maximums. So let's slice it into 0, 90, 180, 270, and then back to 360 for one round. Okay, now we're going to get the basic shape here looking at the unit circle. Once you get the basic shape, you'll be able to memorize it pretty easy. Okay, so let's do the sine graph here in blue, just so it's different than the axis. Okay, so at 0 degrees, sine, which is the y value on the unit circle, okay, doesn't have anything to do with this y. This is just y and x on a graph, okay? That value is 0 at 0 degrees. Okay, we go up to 90 degrees, y is 1. We go around to 180, and y comes 0 again. Okay, and then we look at it and we go, oh, 270, it's negative 1. And then back to 0 for 360. So there's the basic sine graph. Now, how does the curve look here? It's a curve. So if we look at 45 degrees, it's root 2 over 2. So go on your calculator and go, well, what's root 2 over 2 as a value? Take your calculator, go root 2 equal, and then divide by 2. Well, you get decimal 707. So decimal 7, right about halfway, about 7/10 of the way up is here. And then if you go to a 90 plus 45, which is 135, it's root 2 over 2 again. Okay, why is my pen disappearing on me? I must have lost the blue here. Let me get my blue back. So it'd be there. Okay, and then if we're trying to get it in between here, if we go halfway in between 180 and 270, add 45 to that, that's 225. It's negative root 2 over 2, so negative 0.7. And then, of course, if we go halfway between 270 and 360, that's 315, and it's negative root 2 over 2. So there's our basic shape of our sine graph. Looks like this. And that's what it always looks like. And then after 360, if you go around the circle again, it repeats. If you go around the circle again, it repeats. So if we kept this going to like 720 degrees, we get another loop of this. So this is called, this length is called the period of the sine graph. So the period of the sine graph is one whole round of the circle. And then it starts to repeat. So period means when does it repeat after the fact. Okay, that's what we call that. Now this part here, from the very top of the graph to the center line, or from the very bottom of the graph to the center line, we call that the amplitude of the graph. Okay, or it could be here too, right? Okay, this is our minimum value. And this is our max value. So that's the basic shape of the sine graph. Okay? Let's do the same thing for cosine. Okay? We could draw it on the same axis in a different color if we wanted to. Okay? Or we could just do a new one. I'm going to do a new one because I've labeled this one up a little bit. But you can still use the same axis if you want. It'll be the same 1 to negative 1 axis. So I'm just going to draw it again. The basic shape of the cosine graph. Okay, so we're going to go again. I'll use red at the same time like I did last time to label the axes. So 0, 1, negative 1, 90, 180, 270, and 360. Okay, now the difference between the cosine graph and the sine graph, so if we're doing y equals cosine x instead, is where it starts. Okay, so we'll do it in blue again. Okay, at 0 degrees, the cosine, which is the first point, is 1. At 90 degrees, cosine, which is the first point, is 0. Again, if you slide over to 180, cosine is negative 1 over here. Okay, and then when you come back up to 270, it's back to 0. And then it returns to 1 at 360. So it has the same basic shape. Now, if we're looking in between at 45 degrees, you can see that it's root 2 over 2. So that's that 0.7. So somewhere about here. If you're looking between 90 and 180, halfway in between at 135, it's again negative root 2 over 2. And then again, if you slide around to 225, it's negative root 2 over 2, which is that 0.7. And then up here between 270 and 360, which is 330, 45 degrees between, 315, pardon me, it's again root 2 over 2. So there's this basic shape of the cosine graph. Now the tangent graph is a little bit more complex to draw. Okay, again, we could label this up. This is our max, min, our amplitude. That's one period till it repeats itself. So cosine kind of looks like a, I don't know, like a dip going like this. If we actually took this and laid it over top of this, if we move sine back 90 degrees, it becomes a cosine graph. That's how they're related. If you took this and just shifted it back to here, you would get a cosine graph. Okay, but they start at different points. So that's sine and cosine. Okay, that's the first two primary trig graphs. They are very, very similar. The only difference between the two is that cosine starts up high and then goes down. So I always get it. I just always memorize the four major points around the circle. Okay, for sine, you go 0, 1, 0, negative 1, 0, as you're marking in 90 degree increments. For cosine, you start out at 1, you go 1, 0, negative 1, 0, 1. And that's how you get your basic shape, because you know they curve like this. So tan, though, provides us with a little more of a challenge in terms of getting it, because it's not here to look up. So we can do a couple of things with it. We can use our trig ratios to figure out what it would be at each point around the circle, or we could use calculator as well. Okay. So it really depends. So we're gonna do it with the trig ratio thing. So I'm just going to go to the next page here. There we go. And we're going to close this one up and open up my outline here for that. Just give me a second to pop it open here. Oh, my mouse is giving me a, there we go. Okay. All right, so we're going to do the tan graph. Okay, so we remember basically tan theta equals, okay, if we're thinking of our formulas from the chapter 4, tan theta is opposite over adjacent, y over x. So let's start with 0 degrees. Or, sorry, theta equals, and we'll start with 0 degrees. So this is for tan theta. Okay, so at 0 degrees, looking at our unit circle, y is 0, x is 1. So that equals 0. So tan 0 starts right at the 0 mark. Okay, and then we'll do 90 degrees. Okay, so at 90 degrees, if I look up there, y is 1, x is 0. So this equals an undefined. When something is undefined in a graph, you get an asymptote, okay, which is basically a line that's not part of the graph. Okay. So now we'll do 180. And if you look at 180, okay, we've got -1 and 0. So 0 over -1. Okay, so this is not really helping us a whole bunch. So we're going to have to go in between these two. So, and then 360 is going to be the same as 0. Zero over, or sorry, got to do 270. Sorry, 270. I almost skipped one there. 270 is -1 over 0, so that's undefined. Okay, so, and then 360, that's going to be same thing as 0 over 1, which equals 0. Okay, so basically, we can draw 2 asymptotes and 3 places of intersection, then we kind of have to figure out the rest. So the rest we're going to have to kind of figure it out between 0 and 90, 90 and 180. And that we're going to, rather than use the unit circle, we're going to go to our calculator so that we can figure it out quicker. Okay, so let's just draw this first. Let's draw these 5 points. Okay, so I'm going to put that up out of view and then draw an axis from 0 to 360. Now, I'm not going to put any numbers on the side because we don't know if it goes beyond 1, because tans, you can actually, like for example, if you took say sine was a half and cosine, or sorry, sine was 1 and cosine was a half, you could get 2 for a value, right? So it could be higher than 1. So all we know for sure is that this is 0. We're going to put our 90 in there, our 180, our 270, and our 360. Just because that's kind of how we don't know the size, but we do know for this is y equals tan theta, y equals tan x, pardon me. Okay, so the first one we do know is what we figured out above here. So we know 3 points of 0 at 0, 180, and 360. So we can go ahead and put and in between are what we call asymptotes, because it's undefined. So when something is undefined, you either have most of the time you have what is called an asymptote, which is what the graph approaches. So it's how we represent that in math is we just put a dotted line. So I'm going to use a straight line tool, and I'm going to put a dashed line for my asymptote right at 90 degrees. Like this, and right at 270 like this. Okay, so now we're going to take our calculator out, and we're going to try to fill in some points between 0 and 90. Is it going up towards that line, or is it going down towards? So with the asymptote, the graph is going to approach the asymptote but never touch it. So let's do 45. So take and go tan 45. Okay, when you do tan 45, you get 1. So let's make a 1 line. Okay, that's fat. I'm going to skinny that up. 1. So tan 45 is right there. Okay, let's go halfway in between tan 45 and 0. Let's go tan 22.5. So tan, remember we're in degrees here, tan 22.5. Okay, I get 0.4. So 0.4 would be right about there. Okay. Let's do tan, okay, 22.5 plus 45 is 67.5. So let's go tan 67.5. Oh my, it's 2.4. Okay, so it's way up here. So this is kind of going and it's approaching the asymptote but never touching it. Okay, so it never touches the asymptote. Okay, now we're going to try, now we want to figure out, is it going to go down and then up, or is it going to go up and make a U here? What's it going to happen? So we got to go in between 90 and 180. So let's do 90 and 180, halfway in between that. Okay, so we're going to go tan 135. Okay, I get -1, so it's down here. I should have put the 1 a little bit less. I'm going to make this one like, so my -1 would be about there. Okay, and then I'm going to go tan, so if we go halfway in between 90 and 135, so that's going to be tan 112.5. Okay, and that's where you get -2.41. So it's going to be down here. Okay, and if you do, just try tan 80 to see what happens. See how close it gets there. So go tan 80. Notice it's like way up there, 5.6. Try tan 85. Tan 85. 11.4, so it's getting way, way high. What about if you go tan 89, which is really close? That's 57. So it's never going to touch this, but it's going to get higher. So this one kind of curves like this. Oops, I missed it. Let me do that again. So it curves. Okay, and it never touches the side, but it gets closer and closer. Okay, what do you think is going to happen here? Do you think it's going to go down like this or up like that? Well, let's check it out. Let's go in between 270 and 180, halfway. So that would be, if we do that, it's 225. So tan 225. 1. Okay, so we're back here again. Okay, and then we're going to be back here again. So we're going to whoops. We're going to have that smooth curve again going upwards. till we, so it's kind of like that. And then this one, okay, so this one's here, this one's probably going to go down, because this here, or sorry, it's probably going to go from here downwards rather than upwards, because these kind of same pattern. So let's check out between 270 and 360. So if you add those two together, you get, if you add 315, so tan of 315. Okay, that's a negative one, so we're right. So it's right in here. And then again down here, and then probably over here somewhere. So okay, that's supposed to look same, but I'm not drawing too straight. But there's your curve. This one would go down there, and this would go up here, and there'd be an asymptote over here. So you can see that the period of tan actually occurs twice in a circle, even though it's split up here. From negative 90 to 90 would be one kind of pattern. 90 to 270 would be a second pattern. 270 to 90 more than 360 or 450 would be another pattern. We'd have, so we actually have two periods in here, and there's no amplitude here. So with tan, there's the period is only 180 degrees, and there's no amplitude. Okay, because 180 degrees between those asymptotes, and then it repeats, right? Okay. Is there a max and min? No, there's no maximum value. If you go on your calculator and go tan 89.9, you get a huge number.
I found the match for my calculator.
What would that be?
It went to 5.7 times 10 to the 30. So
yeah. So the closer you get, the bigger it gets. So at 89.9, it's like almost 600. So it gets huge. Okay. So that's the tan graph. So there's our three basic graphs of sine, tan, and cosine. Sine, cosine are related. Tan is not. So let's do a little bit of a summary of each of these. Now, if I were to go back in here and look at each of these graphs here, and if I were to put in radian measure, you could just say that this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. So it doesn't matter if it's radian or degrees. Radian and degree, this is radians. And the other one is degree. Okay, we use both. But that's kind of how it looks. The same thing here. If you go to the cosine graph underneath here, you could just slap in radians there. 0, pi over 2, pi, and 2 pi, right? Same thing with the tan graph. You can just slap those in. This would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so that's basically it for notes to start here. So now I'm gonna go to Desmos and show you how to use Desmos to assist in graphing, and that'll be it for today. So I'm just gonna pop, you don't need to have a Chromebook handy, but so I'm just gonna show you how Desmos works in terms of graphing so that you can see what it looks like, okay? because we're going to use it a little bit. Now we will do some hand graphing first, but Desmos is there to check. So we'll do a quick check on that. So let me just pop that out of there and open up a new page here to get to Desmos, and I'll bring it over right away. All right, so let's slide this over. Okay, so if we go to our graphing calculator, okay, this pops up. I'll just get this over here. Now, if we want to do sine, cosine, and tan graph, we have to kind of look at this wrench up here. Now, it's kind of squidged in my view here, so I'll just move it over a little bit. This wrench, you click on that, and this is how you set up your graph to be a graph of whatever limits you want, however many degrees you want it, however high you want it, and that kind of thing. So over here we're gonna go in degrees. So switch from radians to degrees. Okay, and we're just gonna do our x-axis. We're gonna go from negative 360 degrees to positive 360 degrees. Okay, and then our y-axis, we're going to go from negative 5 to positive 5, just because we want to put sine, tan, and cosine all in the same graph to see what they look like. Okay, so I'm going to go from negative 5 to positive 5. And that sets my graph up. Okay, so there, if I click that, there's negative 360, there's positive 360 on the edge. Okay, and goes up to 5, goes down to negative 5. Okay, now I'm going to take this and I'm going to, let me just kind of, okay, and then I'm going to put this, and I'm going to do the sine graph. Y equals sine x. Okay, there it is. Yeah, there's 2 periods of it. Okay, we only drew from 0 to 360, but I've got the negative period in there as well. Okay, and then we're going to do y equals cos x. There it is. Notice it's exactly the same, except it starts at 1. Right, 2 periods of that in there. Okay, and of course the tangent graph, the weird one. Now you'll see this one has not 2 periods, 4 periods. Okay, these two are kind of half period there and a half period there, and then 1, 2, 3. Now they don't draw the asymptotes with dotted lines like we do on this graphing calculator, but they're there. They never touch. It never touches at those points, and you see that there it is at 0. There it is at negative 180, negative 160. All right, so there's no real assignment out of the book for this yet until we do a little bit more, but that's it for today. Okay, nice quick class, like I said. So quick class today. I'll put it up online. If you have anything to finish up with your assignment, you can do that. Get it in. I know, Jordan, you got yours in, so you're in good shape. And I'll let everybody go, and we'll see you guys tomorrow. And Jordan, if whatever your postponed golf day is, just send me a chat in the morning, and I'll check it or something like that, or an email when you know. All right. See you later. But yeah, so no homework or no practice today, just some basics. Okay, let me close this up. That's what happens when you go on the same screen. You get the mirror effect. Kind of weird. Oh, and I gotta turn my recording off here too.